I forgot to say that it's absolutely interesting what he's doing. It's about laser technology, and about laser technology is also his speech that we want to listen now. Thank you very much that you're here. And I give you this microphone because my other microphone didn't work.
Okay, thank you very much. So now we're going to the next technical presentation. And I want to start off with one question. Who of you owns an iPhone? It's quite a lot of people. Next question. Who of you knows what WWDC is? Oh. That's getting very thin. Worldwide Developer Conference. That's what Apple does once a year, inviting all their developers in order to present the newest ideas, the newest approaches. What they presented this year was some details about operating systems. So all the operating systems will be upgraded in a couple of months. What they presented there is a new app on their watch. That's a deep breathing app. It's the first exercise for today, so please, all of you, a deep breathing exercise. That is what all those should do now for the next 4 slides who know about laser-based manufacturing. Do that twice and then come up with your answer. Because, oops, this is the first thing. Where do you see a laser in this? Small present. Any of the deep breathers know about laser-based manufacturing? No. Okay. It's drilling holes. You have an injection mold where you press in the molten plastics. And that goes much faster if you drill holes in the back of this mold. Because then the air can go out and the plastic stays in if the hole is small enough. So this one is for me. Next image then, please, if there's someone behind pressing the button. No? Only the first one. Okay, where's the laser in this one? The deep breathers? Okay. This is for structuring metal dies which can then press coins. So you create a structure on the metal, on a very hard metal with ultra short pulse radiation, and you press that onto a metal surface in order to create coins. Replication. So you have the laser process once, the replication process 1,000 times. Where's the laser in this one? At least someone who said something. This is for you. Said laser printing. Yes, sort of. The technology behind that is that you have a plastic substrate, you put some metal layer on top, and then you ablate the metal there where you don't want it. So it's direct manufacturing of printed and flexible electronic circuits. Where's the laser there? Come on, that's getting easier and easier now. Yeah. Laser-based refurbishment. Yes, precisely. What's happening there is you have a nozzle that's coming from the right side. The laser beam is also going through that nozzle, but also powder, metallic powder, is blown through that nozzle, so it melts right before impacting the surface. In this case, it's anti-abrasive coating on the tip of these metallic surfaces in order to increase wear resistance. So all that is exciting. It's all exciting processes. And the key thing about it is you don't see the tool. Laser radiation, or let's say most of the laser radiation, is invisible. It's in the infrared range. So it's a tool that you don't see, that you can operate, that you can switch on digitally and switch off again. So you can operate at a position where you want it. You have to provide tools in order to guide it, to bring it to the right position, because we as humans can't see it. So it's a challenging area, and it's an increasing market. So if you look at market figures, then you see this rising slope, and you see the growth being at around 20% per year, 10 to 20%. So it's in a market which really has a huge potential, and just most people say it's just started to really go faster, and it also enables 3D printing, so metallic processes by laser-based manufacturing. There are two projects currently running in the I4MS initiative. The first one is Apollo. Gediminas Ragikatis is the coordinator of that project, and he will give the introduction talk to the session tomorrow. We will have one practical presentation from Lecher today and one from Apollo. But this is just the concept of Apollo, binding together a hub of application labs involving SMEs, end users, and the research organizations, the known I4MS initiative. They combine 5 laboratories and have 7 users and 7 suppliers in phase 1, and now look at another 6 applications. Clustering of that area is thin films, laser surface texturing, so mainly micro machining. Lecher, and I want to elaborate a little bit on this one. Lecher has teamed together suppliers, users, and research technology players in such equipment assessments. So we call it laser-based equipment assessment, with a clear idea of having a supplier that has an idea how to solve a manufacturing problem, to have the user that is really representative for his area of industry, and talk to them together with the research organization in order to give scientific backup. And while this is more or less the overall setting, this is really special. We have defined 4 phases in order to conduct these equipment assessments. And the first one is that the end user, the supplier, and the research organization really sit down and discuss, what is TRL for me? What is technology readiness level? And that differs from application to application. You cannot compare one laser to the other if you use it for a different process. So it's a real huge task and a premium initialization in order to have a successful implementation and development and improvement in task 2. Task 3 is then this validation in a production-like environment. And we added task 4 to have a real resume of what was achieved within the assessment and what has still to be done in order to bring that solution, I call it now solution or prototype, to the market. So we span this entire cycle, guided by a set of tools that accompany all these single steps and collect the information, structure it, and so on. And this morning I tried to emphasize that there should not be any called experiment or laser-based equipment assessment without a true business case behind it. And in this case, and that also perhaps differentiates Lecher and these initial projects under the I4MS umbrella, the business case was already more or less there before starting task 1. So there was a user with a manufacturing problem, and there was a supplier who had an idea on how to solve that. Then there came the risk, the development, and all that behind. But to make that absolutely clear, I think the benefit of the I4MS initiative, the benefit of all these approaches is to have this real identification of what needs to be done and what for. So this resumes a little bit to that these teams join their forces in order to agree on these challenges and really to embrace them. To focus on the revenue streams. So are we going to have new people being employed? Will we have 1 product or 2 products in the end? What are our markets? And with the overall aim to increase technology readiness level, and with a future exploitation focus, which we also carried through all these 4 phases. How do we take it forward? That was from last year. The big question, but I want to put that again onto the screen. We have 6 competence centers. We already have 14 success stories. 1 is not yet fully finished, but it's close to. We have 14 new solution ideas currently. And we're increasing the project to 70 partners, and that is a bit of a problem of managing that one with all the registration behind. But we're running up to having real 31 equipment suppliers with new solutions. So you can follow all that to the next phase through all the known channels. Been talking about that, Twitter, LinkedIn, and so on. So also again, to re-emphasize that one, I think I4MS, the overall CSA activity is a huge benefit to all the projects below, because it's the single entry point with, as Sylvia just explained, 3,000 people being on the newsletter. So now a speciality to you. I just do this cross-moderation myself. Carlos Oriach from Monochrome was planned to do this presentation that I'm loading here now. And again, this is exactly one of the points why this I4MS edition initiative is nice. It's an SME, there are 30 people, and he, as one of the responsible persons, was just called for a customer troubleshooting issue. And that's a situation that we saw while conducting La Chaire, while conducting the first 14 assessments. These SMEs are often bound to trying to do their business, so they're tied up in everyday tasks or in rushing for solutions, momentary solutions. And a great benefit that we see in the I4MS, in La Chaire, I can't talk about the others, but what we see in La Chaire is that this collaboration between research center and SME just keeps the thing running. So you have the one benefit of having a clear case identification, a scientific backup, but also this driving force of the RTD looking after the project, teaming together the users and the suppliers. So what they were facing was, sorry, not what they were facing, what the customer was facing was trying to create tracks for seating. It's Johnson Controls. They produce, you all know these seating tracks that you have under your car seat, where you just pull a line, go back, pull a line, go forward. These have to be quite strong, but they also have to be quite light. And there are materials available, high-strength steels, which can be used for that. But it's hell of a trick to get them into the right form. So you have to heat up the material in those areas where you need to bend them, and you don't want to heat the material up too much, and you want to do it eco-efficiently. That's why the headline of this one is, have that in a resource preserving way. So the idea was to try to come up with a laser-based solution which just heats in this bending area, which you see just down here. So on the left side, this is the cold form one. Here behind, that's a breaking of the two pieces. And here, this is just perfectly okay. And all that had to run in an environment where there's a lot of vibration, where they didn't want to provide extra water cooling, which has to be special for the lasers usually, but they wanted to use standard tap water in order to lower the cost. And the solution really needed to only focus in this area in order to not modify the rest of the material properties. What you see there in the black and white image, SMILE, that's when you align laser diodes, single laser diodes, then somehow you get a bending line. You will never make a thin, straight line like you see this down here if you can't provide the technology to get that right. So that was the starting point of monochrome. They were able to build alignments of laser diodes with high power, with high reliability, but not in this format. So taking on this challenge, they came up with a box that you see there, which has a optic inside, a good alignment of all these single lasers, providing that kind of energy input towards the workpiece. That were the standard products, and this is the way they went. So they went from experience in space, medical, and other specific applications to this application at industrial requirements. Robustness against vibration, standard tap water, thin line, high energy, and being perfectly reliable. Oh, that's hell of a text. But that resumes that, also again with some of the points that I mentioned this morning in the first part of the session, the benefit of monochrome was increase in visibility. So people didn't know before that they would be able to create such a solution. The user had the benefit of receiving a first-time adoption option of this equipment, but all others also became aware of that solution. So from the starting point of thinking about having some sales figures, this increased rapidly even during the execution of the laser-based equipment assessment. Product development was accelerated, and Lashare Competence Center support, yes, there was a competence which was missing in Lashare. Although we had 6 partners in there, there was no partner which could do a simulation of that heating up and cooling down in that area. So we had a tool in Lashare which was called Resource Challenge. We tried to find a partner, and one of the partners had an idea of who could solve that. So that's again the starting point of being a digital innovation hub, connecting to other competencies. The final solution then is the setup that you already saw in this colorful picture, the solved process challenge for Johnson Controls. They're thinking about really changing over their manufacturing equipment. So we're talking about a production line, not about one machine, but a production line running at full capability. And Monochrome already has created 3 new jobs and expects, due to this increase in visibility, also multiplication of sales, not only selling 10 units per year, but expecting 100 units, even more than that. Confidential, because that's not on the slide. So, thank you for listening to this application example. You will have another one from Arnaud Zoubir tomorrow afternoon, and another 12 which we will not present to you within this conference, which you can look at the website. Thanks a lot.
Ulrich, thank you very much. Thank you very much, Ulrich. That was really, really interesting.